Hi everyone. Today, in hopefully under 10 minutes, I'm going to show you some basic instructions and features in terms of how to use Shapr3D, which is a CAD computer aided design software written especially for the iPad to make great use of the Apple Pencil. And it helps you take, in a very intuitive and straightforward way, your ideas into shapes, products, surfaces, features, and lines to build up something as complex as this car in a set of fairly simple steps. It is a professional CAD software in every right. It's probably not as detailed or featured as some of the more professional versions that are made for manufacturing, which are much better for tolerances and details. But it certainly helps you in terms of the ideation stage and the prototyping stage to come up with something that looks fairly convincing in a fairly short amount of time. I won't be showing you how we did this entire car, but I'll be using the design principle of starting from large shapes and blocks and cutting them away to come at a generally complex set of features by sort of subtractive processes rather than building up surfaces and complex shapes from the bottom up. So let me just start here by drawing a rectangle, which is the side profile of the body of the car. I guess that's the most straightforward feature you can think of. And I've done one which is approximately 1 by 6. One of the great features of CAD is, or Shapr3D, is that you can extrude things. So take a 2D surface into a 3D shape very easily and specify the dimensions. Next thing I'm going to do now is to try to cut away a little bit of material from that block by projecting a plane and projecting the side of the block here onto the plane. So it goes from, again, 3D to 2D. You can look at it head on. And let's just take something that looks like the bonnet. So I'm going to choose a spline here, which is a fairly complex curve defined by a number of points and gradients. It's really important to use as few points as possible to define the slope and the overall shape of the spline if you can. And it's really important as well, as you see I'm doing here, to match the gradient of the endpoints of the spline to the face it should mate with, so it's nice and flat, and you don't have as many discontinuities. So there you go, I've done the bonnet. What I'm going to do now, sort of a reverse extrude. I've just taken that 2D shape, and rather than create a new body, I've subtracted a body, and you can see I've already got something that looks like a slope. Next thing I'm going to do is I'm going to cut the same sort of curves, this time from the top of the body. So I've projected a plane normal to the one we were looking at in the vertical plane. I've projected the top of the car onto it. And now let's just start by maybe cutting away. Let's take maybe the front lights. So let's look at the front of the car here. Where am I going to put it? Okay, let's just go with here, for example. Maybe I'll move it a little bit forward, actually. Again, you want to minimize the number of new points, and you want to try to match them as close as possible to existing ones, so you have less features and discontinuities. Again, here I'm going to make them parallel to the edges of the car, just so I have as few discontinuities as possible. I'll do the same here for the back of the car, something maybe a little bit more gradual. Looks like that. And that. Okay, that's good. Let's select these two faces now and do another extrude. So let's take this face here. There we go. And this face here. There we go. Let's pull them down. And boom, same result. So we've now got something that's gone from basically a shoebox or a block to something that curves in 3D with just a few simple maneuvers. Next thing I'm going to do, and I'm not a car person, but I've seen enough to realize that, particularly on the more modern designs like some of the new Audis and Teslas, they tend to be defined by something called a shoulder line, which is just a line inside of the actual perimeter of the car that helps it transition from being flat or normal to the ground to something that sort of gradually curves into the canopy or the bonnet, the front lights. As you can see, I'm making the shoulder line, oops, sorry, lost the pen, making it parallel to the side of the car, and yeah, that bit should do. Again, not too complex, and my geometry and my proportions aren't the best, but again, this is just for ideation and showing you the basic principles. So another projection, and this is what's really beautiful about it. You can take a 2D line in a 2D plane and project it onto a 3D shape, and you get a line that's actually curving in 3D, if you think about it, excuse me. So let's go ahead and get rid of these lines. We made quite a lot of progress actually, and you'll see in a second why. But this is probably the most beautiful and intuitive part of the whole program, is if you see the car we've currently got has a pretty 90 degrees or right angle indent on the side, whereas the more detailed car you saw I did has something that looks like this nice sloping shoulder line that goes from being about 45 degrees to then something more flat for the lights to light on. So how would you do that on this shape? And I'm not sure if this is by mistake or something that they've preempted the user would want to do, but let's take the sides of this car. I'm just selecting the lines here, so just the edges, and let's just translate them downwards and drag them down as if you were molding a piece of clay. And this is what's really quite amazing about it, is you're doing something subtractive and intuitive, like you were working a piece of clay or chiseling it away, rather than actually drawing really complex surfaces that change in 3D. As you can see, it's already sort of figured out that the center of the car has to stay flat, but then the sides gradually translate from being flat to 45 degrees, and it curves all the way really nicely around the back. So something's starting to take shape here. You're probably missing the key part of any car, which is where the passengers sit, and that is a canopy. And I'm going to go ahead and do that by first selecting the footprint of the canopy. And it's important that I'm using this feature here called offset to take that closed loop shape into something a little bit smaller and project it onto the surface of the car. And this is to allow me to drag the surface up and down vertically in a 90 degrees extrude. And you'll see why this is important in seconds, because if I didn't have it and I tried to take this surface up, what the CAD program tries to do is to match the geometry and the slopes around it so it stays continuous, and it becomes something a little bit more shapeless and amorphous, whereas what we really want, and you'll understand why in a sec, is something that just moves up vertically. Because what we want to do is we want to form the top view of it to match the footprint of where it mates with the car, but we want to draw the side view of it to something that slopes and something a little bit more aerodynamic. So let's go ahead and do the side shape here. Let's do another spline. Again, I'm not a car guy, so maybe this isn't my the best geometry, but let's just take a capsule that looks something like this. Okay, that's a bit too flat, maybe something a little bit like that. Let's drag this bit a little bit backwards. Okay, and yeah, let's put it down. And here we're going to use another feature that is very popular in a lot of CAD programs, which is the intersect feature. You'll see that in a second. Let's take the block we've created, let's take the side profile and drag this through. And we don't want to subtract it, we want to keep it as a new body just for a second. And what we want to do is to ask CAD to use the fairly complex mathematics behind it to say what would happen if you made these two shapes intersect in 3D. As you can see, you've already got the outline of the canopy varying really nicely and smoothly, and I've already done that now. I've done the intersection. I'm just going to get rid of the initial block shapes I got, and voila, you've got a canopy that looks, at least in my eyes, pretty cool. So that's the canopy. Again, this is not a full demo for the full complex car, so I'm just going to end pretty soon with the wheels, but I'm just going to leave a few guidelines so I can cut them out. Let's stay with the side of the car. Let's get rid of the top. Again, you want to draw on a plane that is normal to the side of the car, because the wheels are normal. So let's well, actually, you know what, before that, let's try to rotate the canopy just so it looks a little bit more realistic. And you notice that they tend to slope inwards, and again, that's no problem with CAD. You can just select the no problem with Shapr3D. You can just select the surface itself, and there you go. You can see it's sloping ever so slightly inwards. Okay, so that's the canopy. And you notice that we've done a mixture of sort of starting from block shapes and cutting them down, but also creating some new shapes. So it's a sort of a hybrid approach, as if you were working with a piece of clay. I guess the final bit we need to do is the wheels, which is I guess the most intuitive part of any car. So let's just take this plane. Let's draw a circle. Let's place it there, for example. And select this copy button in a second and pull the other one back. Let's get rid of this line here just so it doesn't interfere with the shapes. Boom, you've drawn it in, it's subtracted it, it's again figured that out intuitively. Let's get rid of the guidelines. And there you have something that looks like the starting point for a a fairly attractive, fairly modern looking car. The point here isn't how accurate this one is. The point is how quickly we've been able to achieve this using some very intuitive and simple gestures. If you are really interested in seeing how I do the full detailed version, do drop me a message on the chat box. But just before I finish, I'm going to mirror this car because if you've been noticing, I've been only drawing half of it, but it is symmetrical around the center of the car. So that's just a very quick idea of how you can get to that stage. And yeah, I mean, just working backwards, that's slightly more geometrically pleasing. This one's even more so. The thing about all these details is they are fairly deceptive. Yes, they are smaller, but it takes a lot more time and effort to go into the real nitty-gritty of doing these sort of aerodynamic lines and these indents and these cutaways and the wheels and the rims. But I can show you that and more if you are interested. I just need to justify the time. But if you would like to see that, and if you found this video useful, please drop me a message on the chat box, and I would love to hear from you.